And our next presentation is next-gen ETL generators. And our presenter is Miljenko Vukovic, data engineer founder at VIS. So, yeah, stage is yours.
Thank you very much. So let me first introduce myself shortly. Hopefully you can pronounce my name. If not, you can just call me Mitch. And you can also add me on LinkedIn if you like. Ask me whatever you want. If you try to sell me something, I will try to answer you. If you want to buy, I will answer you for sure. So, yeah. So here's a short agenda. I will do a little bit introduction just to place ETL generators, or probably it would be more correct to say ELT generators if you don't know what is it, to define it a little bit, and then talk about what we can do using such generators. So let's start from the beginning. This is one typical data infrastructure where we have multiple source systems in a company, like ERP or ERPs, CRM systems, HR systems, and so on. And data engineering role is to bring them all in the same place, like data warehouse or data lake or similar. And then we can do what it's all about. We can do reporting, we can do some analytics, but also in modern times, we use a lot data for machine learning and so on, data science. So some architectures. Historically, you're probably aware, data warehouse is very much all present and popular architecture. Then data lake appeared in the time of big data, where we dumped all the data in the same place, but not much integrated. Then appeared even more modern architectures like data lakehouse that combines the both worlds, that has both data lake for non-structured data and data warehouse structures with facts and dimensions for structured data, and of course, cloud data warehouse. We will talk mostly about this last architectures when we talk about next gen of ETL or ELT generators. So this is one example. This is data lakehouse, at least in my head. So basically, we dump all the data in the data lake, use it as staging area for data warehouse, and we have data warehouse for structured data and some serving layer for using all that data. Now, when it comes to terminology a little bit, when I talk about ETL, I think about all this stuff, right? Because I'm old school, so I'm used to ETL. But nowadays, as you know, a more popular architecture concept is ELT. First extract data, then load it, and only then transform it. So now I guess we are ready for generators. Sorry. Okay, so when it comes to technologies, we have several generations in my mind, at least. When I started about 20 years ago, it was very popular to use stored procedures, especially if the source and data warehouse were on the same technology. It was pretty much straightforward. You would avoid costs of ETL tools. And then, of course, as more and more sources with more and more technologies appeared, you couldn't do it in database, so used blue chip ETL tools like Microsoft SQL Server Integration Services, Oracle Data Integrator, IBM Data Stage, Informatica, and so on. And now, in the modern time, in the time of the cloud data warehouse, we have some even newer generation of tools like dbt or Matillion, or even we can use for transformation time part store procedures. I saw it on several projects, and it's actually pretty cool to see how it's the history repeats itself, right? So hopefully I was clear so far, so I will try to define generators. Basically, ELT generators is what, for example, if you were on data warehousing projects, it was always, it still is very popular to define the data model, facts and dimensions with all the fields and all transformation in spreadsheet. And still it's super popular format for documented database, for making specification before the development. So you have for every fact table and every dimension all the fields with all the source columns and all the transformations that need to be performed to get the target column. And the idea was, why not use this specification to generate ETL automatically without in the ETL tool itself, without any development manual, right? So now, where does it fit in technology stack on the cloud? Well, basically, it would fit in the third point, more or less, just to generate code in the technologies like dbt, Matillion, or Spark, or store procedures, as I said. So basically, the idea is to define the structure, to specify the structure data warehouse, and then generate everything on click. And it works in some cases, believe it or not. Of course, there are some exceptions when you need to do it manually. So basically, the rationale is, except to save some labor on manual development, is also to be in theory technology agnostic. So this means if we can generate ETL from specification in one technology, then at least in theory we can switch to other and then generate it from the same specification in the other technology. At least this is the idea, but I haven't seen it still being used in this way. So basically, as I said, specification, popular part of specification is still popular tool for specifying model is still the best technology, the best software in the world. This is Excel. I guess we all use it every day for everything, right? At least I do. It's the best. So we define here the structure of our data warehouse and generate it. But now, wait. For example, what if we are drafting the code for our fact and dimension tables in SQL? I do it all the time. For example, we have fact tables with a lot of columns from a lot of sources. So I want to find the source tables of these columns. I want to join them. I want to see, do I get the right number of records, aggregate if needed, and so on. And why would I need to write this Excel if I already have SQL? Well, this can be done using SQL parsers, like the one we have, when you can literally parse the SQL statement. It is a rule-based parser, just to say. It's not AI, so I'm not promoting AI here. It's a standard parser, and generate this Excel from SQL. And then in the next step, we can use it to generate a real ETL in any supported technology. For example, we are just working on Matillion. I don't know how many of you are familiar with Matillion. You are, okay. Anyway, because he's working on it. So this is ETL tool, popular in cloud world, that is very much visual. If you worked before on Oracle Data Integrator, you basically draw flows. You don't code, you just draw the workflows. But all these drawings can be downloaded in JSON format, so we can generate this. JSON is, of course, structured. So we can generate the JSON that ends up being imported in Matillion and being represented as this drawing. So this is actually pretty cool. With dbt, it is a bit more straightforward because dbt is very much SQL based. So we can just use this specification to generate the kind of the models in dbt with all the structures, you know, for logging and blah, blah, stores definitions and so on. A little bit more than just SQL. We can use it to generate staging area. It's much simpler, basically, because you are, so to say, copy-pasting data from the sources to the staging area or data lake. Of course, it's not necessarily truncated search. It can be slowly, how do you call it, change data capture or streaming and so on. But usually the templates will be the same for every table. And it's actually quite easy to generate the real integration routine for every table in staging area using generator. It's much easier because it doesn't have transformation between source columns and target columns. Of course, we can use it to generate stored procedure. Here is some Snowflake example, I think, where you basically have a template with all the parts that are standard, like logging, the start of the load, the end of the load, errors, and so on, and put the smart part, the SQL that is typically doing merge, in the middle. So you can just generate it for every table from the Excel I showed. You have templates for facts, for slowly changing dimensions type 1, for slowly changing dimensions type 2. You choose it and generate it. it actually works. I use it on projects all the time. So Google BigQuery is a little bit specific. I put it here because it's maybe not so popular as Amazon and Microsoft for cloud data platform, but actually it can be very economic for small to medium enterprises that don't have like enormous amount of data like telecoms or retails, but normal business. For example, if you are a business-to-business company that has a medium amount of transactions, Google can be really cheap. You can use generators to generate store procedure on Google, but also if you are migrating from a legacy stack, they have their own migration tool, which is actually quite cool. It's also supposed to do similar thing to kind of parse the procedures in Microsoft or Oracle or whatever and translate it to Google's syntax. We can also cover Microsoft. Basically, except generation of store procedures, we can also generate the file export of the pipelines here. So you just upload them to repository, like test environment or whatever, and skip this step. So we also have covered ODI, but I guess nobody cares. We needed to do it on one project, but now it's less and less popular. I think so, at least. Right, I don't have statistics. So now we are approaching the last part. I hope I was clear. You will have a lot of time for questions and answers, so I will be happy to clarify. Basically, which are benefits of trying to automate the generation of ELT, of the integration routines. Of course, it's a boost of productivity, cost saving, but also standardization. And as we said, it's kind of self-documenting because you start from documentation and then get code, not the other way around. Well, a little bit of explanation why I use spreadsheet format as specification, because it's technology independent, at least in theory, and also it improves speeds up onboarding because everything is documented in the same format. And if you're a new developer on the project, you can get much easier understanding what's there. So now to conclusion. As I said, benefits are productivity boost, saving, technology independence, accelerated onboarding. As I said, the Excel specification of data warehouses is still very popular. On every new project I start, they always start with some source to target Excel or something like this. Physical model, dimensional model, these are typical names of the files, so it's here anyway. And if we have everything in Excel, like source columns, target columns, transformation joins, where part parameters and so on, why wouldn't we skip development and try to do everything on click? And it works in most of the cases. And I think I am much faster than I was supposed to be. I don't have any watch, so you have a lot of time to ask.
Yes, there's the time for asking now, for questions.
Please, somebody. Oh.
Thanks for your talk.
You're welcome.
My question is maybe the obvious. How do you deal with the changes, like ongoing maintenance and enhancements? Do you do that all in the Excel source to target mapping, or how do you go about those things?
That's a good question.
And also then shipping those changes from dev to test to prod, whatever.
Yeah, it's a good question. You need to be extremely consistent with keeping everything in Excel, because if it kind of gets apart, I did it on one like a small project, then it gets impossible. Because if you start manually like updating the code, then it's very hard to synchronize it back. Yeah. But when it comes to deploying, as you asked, to production and so on, we don't use generate on this part. We just use normal deployment procedure. We just generate it on test environment or development environment wherever we do development, and then do normal deployments.
Any more questions?
Well, I was or clear or nobody understood anything. So, thank you.
Yeah, so thank you.